Dear students, Assalamu alaikum. Welcome back to our regular chemistry first paper online class English version arranged by KPB School and College. Our today's topic are electronegativity and ionization energy under chapter 3. The title of the chapter 3 is Periodic Properties of Elements and Chemical Bonds. At first, I'm going to discuss electronegativity, the relative tendency of an atom in a molecule to attract a shared pair of electrons towards itself is termed as its electronegativity. For example, if in a molecule AB the shared pair of electrons are attracted more towards A, here these shared pair of electrons are more attracted towards A, then the electronegativity of A is considered to be more than B. That means the electronegativity of A is greater than B. For another example, in HCl, chlorine is more electronegative. That means the electronegativity of chlorine is greater than hydrogen. And the electronegativity of an element is a unique and fundamental property. Electronegativity depends mainly on three factors. Number one, hybridization. Number two, size of atoms, that is atomic radius. And number three, attraction of the nuclear charge on the electron of outermost shell. At first, I would like to discuss hybridization. Hybridization is the idea that atomic orbitals fuse to form newly hybridized orbital. That means two orbitals hybridize and form another new hybridized orbitals like this. This is a s orbital. You know the shape of s orbital is spherical, and this is p orbital. When these two orbital hybridized, it produce like this. At first is produced like this, and finally this hybridized orbital look like this. And for this hybridization, electronegativity is affected. Now, how the electronegativity depends on size of the atom. The smaller is the size of an atom, greater is its tendency to attract toward itself the shared pair of electrons. That means the electronegativity is increased. Now, attraction of the nuclear charge on the electron of outermost shell. When the charge of nucleus is increased, then the attraction of nucleus and the outermost electrons is more, and the outermost shell is shrinked, and that's why the atomic size is decreased. For this reason, then the electronegativity is increased. Now, I would like to discuss how the electron changes in a period. For example, if you look at the table, you can see here that uh, in period 2, the electronegativity is increased gradually. And for another example, for period 3, look here, electronegativity is also increased gradually. So, we can say that the electronegativity of elements in a period increases from left to right. Now, what is the explanation? It is due to the fact that in a period the nuclear charge of atoms increases and the atomic radii gradually decreases. So, the attraction of the nucleus towards shared electrons, electrons increases. That's why in a period electronegativity increases as the atomic number increases. Now I am going to discuss how electronegativity changes in a group. If you look look this table, you and observe this table, you see that from the above data we can uh, tell that in going down a group, especially S and P block elements, the electronegativity values decrease. Look here, if we go down in a group, electronegativity decrease. Now, what is the reason? In going down a group, there is an increase in size of the atoms because an additional extra shell is added for every element. If we go down groups, we know that with the increase in size of the atoms, the corresponding electronegativity of the elements decrease. That's why when we go down in a group, its electronegativity decrease. If we summarize the total discussion, we can say that electronegativity increase in a period if we go left to right and decrease in a group if we go top to bottom. Now I am going to discuss about ionization energy or ionization potential. The amount of energy needed to remove the most loosely held electron from an isolated atom of an element in the gaseous state. This word is very important in the gaseous state is called its first ionization energy. In fact, the amount of energy needed to produce 1 mole of positive ion from each neutral atom is called the first ionization energy. For example, when magnesium atom give up a electron and produces magnesium ion, then its first ionization energy is plus 738 kilojoule per mole. Similarly, the energy needed to remove an electron from the unipositive ion is called the second ionization energy. For example, when magnesium ion give up an electron, then it produces magnesium 2 plus ion and its ionization energy is 1450 kilojoule per mole. Usually we mean by ionization energy the first ionization energy and it expresses IE. Ionization energy is expressed by IE or IP, that means ionization potential, and its unit is calorie per mole or kilojoule per mole. And in this case, first ionization energy I express it by E1. First ionization energy is less than second ionization energy and second ionization energy is less than third ionization energy. Now, ionization energy is also a periodic property and it depends upon three main factors. These are size of atom, atomic number or charge of atom, shielding or screening effect. The bigger is the size of an atom, that is, the distance of external electrons from the nucleus is larger, lesser will be the attractive force of the nucleus. So it becomes easy to remove external electron. As a result, the value of ionization energy becomes lower. You know, in the center of an atom there is a nucleus, and if the distance of the external electron, that means outermost electrons, is larger, that means outermost shell from nucleus, the distance of outermost shell is larger, then attractive force between nucleus and electron is lesser and it becomes easy to remove this external electron, and that's why the value of ionization energy becomes lower. And atomic number or charge of atoms. When the atomic number increases in a period, the nuclear charge increases. So the external electrons are attracted strongly by the nucleus. Hence the ionization energy increases. That means if atomic number increase, the number of outermost shell's electron also increase, and that's why the these electrons attracts it strongly the nucleus, hence the ionization energy increase. And lastly, shielding or screening effect. The electrons in between the outermost shell and the nucleus is called the core electrons, have a shielding effect on the attraction between the nucleus and the external electrons. This shielding effect is just opposite of the attractive force. So, higher is the shielding effect, that means more core electrons, lower will be the value of ionization energy. Look here, this is nucleus, and and this is the outermost shell's electron, and these are the core electrons. These are the core electrons, and if the number of core electrons increase, the opposite of the attractive force is also increased. That's why higher is the shielding effect, lower will be the value of ionization energy. Now I am like to discuss how ionization energy changes in a period. For example, if we see the second period elements, we see here that ionization energy of lithium is 539 and beryllium is 932, and if we go left to right, we see here ionization energy is gradually increase. Because if we go left to right, the atomic size decrease. That's why ionization energy is increased. But uh, there are some exception. Uh, the ionization energy of beryllium is 932, is higher than that of bronze, that is 821, and look at the ionization energy of nitrogen is 1453, and oxygen is 1362. These two are exception. Now I will give the explanation of it. The above fact can be explained on the basis of electronic configuration. We know that the completely filled orbitals and half-filled orbitals are more stable. So, more energy will be required to remove electrons from these. As a result, the ionization energy will be higher. If we compare the electronic configuration of boron and beryllium, we look that 1s2, 2s2 and 2p1, and the electronic configuration of beryllium is 1s2 and 2s2. We, we see here the electronic configuration of beryllium is filled up 1s2 and 2s2 orbitals, and B has single electron. Boron has single electron in 2p on orbital. So boron needs laser energy to remove the 2p1 electron to attain inert gas configuration. So the ionization energy of beryllium is higher, although its position is before boron in the periodic table. And secondly, if we see the electronic configuration of nitrogen and oxygen, the electronic configuration of oxygen is 1s2, 2s2 and 2px2, 2py1 and 2pz1. On the other hand, the electronic configuration of nitrogen is 1s2, 2s2, 2px1, 2py1 and 2pz1. From the above electronic uh, configuration, we can say that it is half-filled p orbitals for nitrogen. On the other uh, nitrogen, so a little more energy is needed to remove an electron from nitrogen. That's why nitrogen has its first ionization higher than oxygen. This exceptional according to position in the periodic table. Oxygen is assumed to have higher ionization energy than nitrogen, but oxygen but oxygen has no full filled or half filled p orbital. On the other hand, nitrogen has half filled p orbital. That's why the ionization energy of nitrogen is greater than oxygen, although the position of nitrogen is before than oxygen. Now I am going to discuss how the ionization energy changes in a group. Look at the table. In a group, as we go from top to bottom, the radius of atom increases. look here, the radius of atom increases if we go top to bottom in a group, and as size increases, nuclear attraction force to outer electrons decreases. So the ionization energy in a group also decreases. Look here, the ionization energy of group also decreases, because if we go from top to bottom in a group, the atomic radius increase, and that's why the attraction between the nucleus and outermost shell's electron is decreased, so ionization energy also decrease. Hope this class was helpful for you, and these two are very important topics. So practice more at home. No more today. See you again. Stay safe until then. Take care. Bye.